Hey guys, today's video is about model evaluation. This is a super important and broad topic, but don't worry, we'll go through all the concepts in detail, just hang in there. So, there are four main topics I want to discuss, which are confusion matrix, validation method, ROC curve, and other measures. We'll break these topics down into smaller parts, and today we'll focus on accuracy and error rate in confusion matrix. To begin with, confusion matrix is a tool used to analyze the performance of binary classifier, and it's also called error matrix. By binary classifier, we mean the classifier that predicts two and only two outcomes, and the outcomes are typically denoted as positive and negative. The basic structure of confusion matrix looks like this. The rows represent the actual classes. In other words, it's the actual data we collect, and the columns represent the predicted class by the model we want to evaluate. Okay, the top left cell is called true positive, because for the data points belonging to this cell, they are positive, and the model also predicts them as positive. This prediction is correct, so we call it true, and the predicted class is positive, so we combine them to be true positive. Then, the bottom right cell is called true negative. Just like true positive, true negative is the correct prediction, but the predicted class is negative. Next, the bottom left cell is called false positive. Think about the way we define true positive and true negative, and try to figure out why this cell is called false positive. Basically, the actual class is negative, but the model predicts positive, so the result is wrong or false. Further, the predicted class is positive, so we call this false positive. The takeaway message is that the positive or negative here refers to the predicted class, not the actual class. Last, the top right cell is called false negative. Now pause for a second and think about why. I'm sure you all figured out it's a false prediction, and the predicted class is negative, so we call it false negative. The last thing is we typically use the abbreviation for these terms in data mining. For example, TP stands for true positive, FN stands for false negative. Alright, now you understand what confusion matrix is, we can move on to accuracy. Accuracy is the percentage of correct classification among the dataset, and it's also called recognition rate. In fact, you don't have to memorize the formula, just think about which terms in the confusion matrix represent the correct classification. One thing to note is that the positions might change, because of the ordering of row and column index might change. Therefore, the formula is TP plus Tn divided by TP plus Tn plus Fp plus Fn. The denominator here is just the total number of data points. TP and Tn are the correct prediction since the predicted class aligns with the actual class. And yes, accuracy is such simple concept, but if you are still not sure about this, rewind for a second to review. Next thing we are going to talk about is the error rate. Error rate is the percentage of misclassification among the datasets. Again, please think about which terms represent the incorrect classification or prediction. Yes, you are right. The error rate is just Fp plus Fn divided by the total number of data points. Fp and Fn represent incorrect classification, since the corresponding row and column indices are different. And that's the idea of accuracy and error rate. Let's look at an example. But to be honest, we just plug in the formula and there is nothing particularly interesting here. Say, the model wants to predict the result of medical test, and here is the confusion matrix. The first thing we do is to label the positions. For instance, the 100 on top left cell is true positive, since the actual and predicted classes are both positive. So we put TP next to it, and you can infer the rest by yourself. Then, the accuracy is the percentage of correct classification, which is 0.936. The number in the numerator is TP plus TN because they both start with true. Next, the error rate is the percentage of incorrect classification, which is 0.064. The numerator is the number of data points belonging to FP or Fn, since the prediction is false. That's it. The calculation of accuracy and error rate is just like this. But, as you might notice, these two numbers add up to 1. In fact, this is not a coincidence. They are complementary concepts. In other words, accuracy is 1 minus the error rate, and the error rate is 1 minus the accuracy. However, accuracy and error rates are not perfect, and unfortunately, they are often biased. But we'll stop here for today and talk about their problem in the next video. Thank you for watching my video and see you soon.